All right, welcome back, everyone. Today I'm going to talk about the product rule, which we see on the screen here. It's some formula we saw in class that might feel a little mysterious to you. And I'm going to talk about why it's true. Right? So math is not just a bunch of mysterious formulas. There's actually a lot of intuition, and all of these things are ultimately reasonable. And so that's what I want to talk about today. And so to see why the product rule is true, we have to use an example. We're going to use an example of revenue. And we're going to remember that the derivative is measuring rate of change. Right? It's measuring how our function is changing. And so, for instance, we often think about this as slope on a graph. So if we're looking at a graph of profit, then if the profit is getting bigger and bigger and bigger, that graph is really steep, then that means that our profit is changing really fast. Right? And if we're looking at a graph of something else like temperature, and if the temperature also has a really big slope on that graph, then that's going to mean that our temperature is changing really fast. And so we're going to try and understand how to study this change in the context of revenue. So let's imagine we're selling cookies, and the revenue is the money we bring in. So that's going to be the number sold times the price. And so I'm going to use the letters N and P for the number sold and for the price, and R is going to be the revenue. And we want to ask, how should the revenue change, so rate of change of revenue, as the price and the number sold are changing? Right, so imagine you're selling more and more or less and less, and the price is getting more and more expensive or maybe less and less expensive. How does that influence the revenue? Right? And so our suspected answer from the product rule says, well, it looks like we're looking at a derivative, because that's rate of change. And if we are multiplying two functions together, then the derivative should be given by this formula here. Right? Take derivative of 1 times the other function, and then sort of add this extra term. Let's see what's going on. Let's try to use common sense to see if we can understand this. So let's do a simple example first. So let's say we've got a business. Currently, we sell cookies for $4 each, and we sell 100 a month. Okay, that means we make $400. And now let's imagine something changes. We're going to keep the price the same, but we get more customers in, right? So now we're going to sell 5 more cookies a month, right? So that change in that number is now changing. It's increasing by 5. If we were to graph how the number sold is changing, it would be going up at a rate of 5 per month, so that's slope 5. And so if we're selling 5 more a month, how does our revenue change? Well, if we're going to sell 5 more cookies, they're $4 each, it's going to go up $20, right? 5 more cookies, $4, that's a change in revenue at $20, right? And so that's pretty reasonable. Now, what on the other hand, same situation, say we don't sell any more cookies, but we increase the price. Right? So let's say we still sell 100 cookies, but we increase the price by $2. Right? So if we increase the price by $2, well, I guess we're going to make $200 extra because we're selling 100 cookies, $2 more each month. That's going to bring in an extra $200 of revenue. Right? So now, what if both of these things are happening at the same time? I've got some colors in here. Bear with me. I want to track sort of where these colors are going. So same situation, $4 cookies, $100 a month, but things are changing. Over the course of a month, the price is going to be going up $2. You can imagine maybe it's going up a few cents per day or something like that. And over time, the number we sell is going up on average about 5 cookies per month. And so already I've got these encoded here. We've got the derivative of P is equal to 2, the derivative of N is equal to 5. And we want to know how our revenue is changing, right? So our prediction, I think, is that, well, it's probably a combination of the two things we saw before, right? Increasing the price is going to bring in some extra revenue. Increasing the number of customers is going to increase the revenue. And so we would kind of predict that we should be adding that $20 and that $200, right? And if you try to remember what those numbers were, well, we were really multiplying 2 times 100. That's how we got 200, and 4 times 5, that's how we got 20. And those were exactly these numbers here, that the rate that the price was changing times the number, and then the current price times the change in customers, right? And so maybe that's a reasonable prediction. If that sort of sits well with you, then maybe I've convinced you that the product rule is reasonable. On the next slide, I'm just going to do it in one more way that should maybe feel a little bit more satisfying, right? So I've added a little bit in this slide. It's the same slide as before, except I've sort of emphasized this word currently, right? So currently our cookies are priced at $4 and we sell 100 a month. So I've sort of thought of this function P, our price function, as really a function that changes, right? At this point in time, at time 0, they're $4. And right now the number we're selling, right, is 100 a month. So that's super reasonable. And we can imagine that might change, right? Maybe in 2 months or in 3 months, these numbers could be wildly different, right? So all I kind of know is that information now. And I also know I've been measuring, and I know that the price is going up $2 per month. That's why we've got P prime of 0 is 2. So the derivative of our price function is 2. That slope is 2. The number sold is increasing by 5 cookies per month. That's why I'm saying that right now, it seems like the way that my number sold is changing is 5. And again, all this stuff could change in the future, right? In the future, maybe these numbers will be different. So that's why I'm emphasizing this currently, this right now, and I'm sort of thinking about everything sort of right now at time 0, right? So let's model this. Let's use the fact that we can say, well, right now, I've got a pretty good model for my price and for my number, right? In fact, it seems like if I think about this, roughly my price right now is $4, and it's going up by about $2 per month, right? Again, that might change in the future, but right now, I feel like this is a pretty good approximation. And right now, my number is going to be given by 100 cookies plus 5 for every month, right? And so if that's my formulas, if these are really good approximations for my price and for my number, then if I want my revenue, I should just multiply those together. And so let's do that. So I'm going to take these numbers, I'm going to multiply them together, and I'm focusing on these middle terms here, and you'll see why in a second. So I FOILed it out, and now I've got my formula for R of t. It's 20t squared plus 2 times 100t plus 4 times 5t plus 400. And now I'm going to take a derivative. And all I need to know to take this derivative is the power rule, right? This is what makes it so cool. We don't need any fancy tools for this. And so what's the derivative? It's going to be 40t plus 2 times 100 plus 4 times 5. And now we look at that and we say, well, that's representing our change in revenue. And I want to know how fast our revenue is changing right now based on the data that I have for time 0, for our current moment. And so I'm just going to plug in t equals 0 because that's all I know about. All I know about is the current moment. And when I do that, this 40t is going to go away. And what are we left with? We're left with 2 times 100 plus 4 times 5. Hey, that's what we thought it was. We're seeing that 200, which is the orange number times the red number. So that's the derivative of p times n. And then we get the blue number times the green number, which is going to be our price times the derivative of the number. So sure enough, this gave us exactly the product rule. And this can actually be made into a completely rigorous proof, right? We can say, well, in general, if we have a function that's a product of 2 other functions, maybe it's area of a rectangle where we multiply the lengths of the 2 sides. Or maybe it's revenue where we're multiplying cost or price by the number sold. Well, if we approximate each of those functions with a tangent line, as we did here with our 2 linear functions, and then we multiply them together, and then see what the derivative is using that power rule, we'll get exactly this formula. So this really speaks to me as to maybe why the product rule is reasonable. If you search on YouTube, there are lots of other videos where people go through kind of a rigorous proof with limits. There's some videos where people sort of think about area and they draw some pictures of things changing. Please comment, please email, let me know your thoughts, and we'll see you soon. Thanks for watching.